Alrighty, I would like to give you the equation for this piecewise graph. I'm going to start here on this farthest left function. It is a graph of a line. So how do we get the graph of a line here? Well, you can use slope-intercept form, but because this graph does not intercept the y-axis, I'm actually going to use a different format I like using. The different format I like using is the equation y equals a x minus h plus k. Okay, a equals the slope of the graph, and hk is a coordinate xy on the graph. It's some coordinate. It doesn't matter which one, just some coordinate on the graph. All right, so if we look at this graph, let's just find the slope. Hopefully you can see the slope here would be rise 1 over 2. So you can see for this blue graph, your slope is 1/2, and you can choose any coordinate. I'm going to choose a coordinate -2, 1. I chose -2, 1 from that dot right there. Okay, so this is your h, this is your k, and the slope is your a value. So we're going to do 1/2 x, the opposite of -2 would be a +2, plus 1, and that would be the equation of the blue line. And for what interval is that? Well, if you look at this carefully, doesn't that interval for this blue line start at -2 and go to the left? And here's an open circle here. So how do we say -2 and to the left? We say that as x is less than -2. Okay? If this was a closed circle, it would be less than or equal to. Now next, I am going to focus on this little red dot, because the dot is a part of the function. So this red dot is at -1, 3. So let me write that down. That coordinate would be -1, 3. Okay, xy value. So it's kind of weird is, how do you write an equation of -1, 3? Well, -1, 3, the output is 3. And for what interval is that? Well, it's for the interval when x equals -1. It's a little weird. It takes a little bit of practice learning this. But again, when x equals -1, the output is 3. Okay? For values less than -2, this creates the outputs. That's how you get the blue graph, the red dot, and so forth. So that would be the equation for that red dot. Next, we're going to get this green line right here. All right, so we're going to finish off with this green line. So to get this green line, well, I could use this same formula. But since this one actually goes through the actual y-intercept, I can actually just use slope-intercept form. It's a little bit easier. So let's first think, what's the slope? Over 1, down 2. So we're going over 1, down 2. So you should know for this green graph, my slope is -2. And what is your b value, or your y-intercept? Well, it looks like it crosses at 4. And we should know from the formula y equals mx plus b. We should be able to make the equation. So the equation would be -2x, all right, plus 4. And that would be for what interval would this be? Well, it's for the interval x values starting at -1, and we're going to the right. So we do greater than -1. So that would give us the equation of this green line. Now you could also use this for that green line. Let me show you, you could have totally used this formula too. Watch this. For the green line, what I could have done is I could have put -2, okay, x, and use the coordinate. Let's just use this coordinate right here. This would be -1, 6. So I'm going to put -1, 6 in. So it'd be the opposite of -1 would be a +1 plus 6. So I could be using, again, this formula right here. That's what I did. I used -1, 6, and there's my slope. But watch this. If I were to distribute this out, I'd get -2x, oops, let me go back there, -2 plus 6, which when you combine those, don't you get -2x plus 4, which doesn't this match that? So you could have used this whole process, but it's easier since it crosses the y-axis to just use slope-intercept form. When it doesn't cross the y-axis, that's why this one can be a lot easier for people in those situations.